This is our advanced sensor trainer board. In this board, there is the facility to interface the different instrumentation sensors like load cell, LVDT, strain gauge, and different temperature sensors with this trainer board. And in this trainer board, there is also the facility to interface the smoke sensor, relay, speed sensor with the sensor trainer board. And in this, there are the different sections. These sections are load cell, then digital voltmeter section, then LVDT section, then after that smoke sensor and relay section, and there is a section for different temperature sensors like thermistor, LM35, RTD and thermocouple. This is the section for the strain gauge. We can interface the strain gauge sensor through these sockets and get the output in form of the voltage into our digital voltmeter. Now this is the section for power supply and amplifier section, and this is the section for the speed sensor. We can get the value of RPM of the motor through this. So this is the brief introduction of the advanced sensor trainer board. Now to do the experiments, first of all switch on the power supply. Now this will show the value on the voltmeter section, that is 0.01 and 2. Now first of all we have to check the power supply. So connect the 5 volt power supply with the voltmeter section through patch cord like this. It is giving us the value of 5 volt power supply into our voltmeter. Now we have to connect the -5 volt supply and check the value into the voltmeter. Now similarly the another socket is of 12 volt in the power supply section, and we can check the voltage in the digital voltmeter, that is 12 volt. Now to do the experimentation with the different sensors, we have to connect the sensors and connect the power supply with the individual section. So first we have to do the experimentation of the load cell. So first of all connect the -5 volt with -5 volt of the power supply section, ground to the ground of the load cell section, and 5 volt to the 5 volt option. Now this is our load cell sensor, and these are the banana cables of the load cell sensors. Now connect the sockets according to the color combination, that is red socket to the red, green to the blue, black to the black and yellow to the yellow socket. Now connect the amp output to voltmeter. And ground to the ground of the voltmeter. Now put some weight on the load cell. It is giving some readings. Now this will show that our sensor is in working condition. Now connect the M output to the IN1 section and connect the output to the voltmeter section. Now put the weight into the load cell sensor and note down the readings changing into the voltmeter. As you increase the weight into the load cell sensor, your reading will be increased. So likewise we can increase the weight. The voltage is increasing, and as we remove the weight from the load cell sensor, our reading will get decreased. This is the interfacing of the load cell sensor. Similarly, to do the experimentation with the strain gauge, connect the power supply as given in the section, and this is our strain gauge sensor. So connect the section as given, black socket to the blue socket, one single red socket to the red and another socket to the black socket. Similarly, connect the output of the amplifier to the input of the instrumentation amplifier and connect the output one to the voltmeter of the Tenor board. Now when we put some weight into the strain gauge, our readings will get changed in the millivolt. Now to do the experimentation with the different temperature sensors, first of all we have to do with the thermistor. So connect the 5 volt connected to the 5 volt of the thermistor, then ground to the ground, and output of the thermistor to the positive of the voltmeter, like this, and ground to the ground of the voltmeter. Now as we increase the temperature of the thermistor with the heating element, the temperature is increased accordingly and the voltage starts increasing. This is the experiment of the temperature sensor. Similarly, we can do this experiment with the LM35 section. So connect the 5 volt to the 5 volt of the LM35 section and ground to ground. Now connect the output of the LM35 with the voltmeter section. This is showing us the 30. As we increase the temperature, as we heat the temperature sensor, that is LM35, our voltage is start increasing as the temperature is increased. Similarly, we can do the experimentation with the RTD. So this is our RTD sensor. We have to connect this with the RTD section, and we can similarly note down the readings in the voltmeter. Now this is showing us the value. As we produce heat into this RTD, the value will going to increase. So this is showing us the, after heating, it will showing us the value 3.70 or 71 volt. Similarly, we can do the experimentation with the thermocouple. So we have to connect the thermocouple sensor in the thermocouple section and positive terminal to the positive of the thermocouple and 5 volt to the 5 volt from the main power supply. Now it is showing us 0.28 value. As we increase the temperature or put the heating element into this, the value starts increasing. This is the experiment for the thermocouple. Now to do the experimentation with the LVDT section, connect the LVDT sensor to this DB9. Now connect 5 volt, minus 5 volt and output of the sensor socket with the supply and ground, and output of the LVDT connect to the voltmeter. As we press the LVDT sensor, its value is increasing from the set point to the minus value. This is the LVDT sensor, this is the core, and this is the main winding of this. As we put the core inside the winding, value will start decreasing up to 0, that is null point, and after that when we again insert the core inside the windings, the value will go in the negative. So this is the mechanism of the LVDT. So this is the working of the LVDT sensor with this strainer board. Now similarly, this is the section of the speed sensor. This is the section for the speed sensor. On the LCD it is showing the advance and RPM of the motor. Now we have to start this motor through this potentiometer. Now it is showing the motor is 12% running and RPM is 117. As we go increase the potentiometer, our RPM starts increasing. On the 100%, it will show the maximum RPM of the motor. At 100%, the motor is rotating with the full speed, and the speed is sensed by the sensor, that is speed sensor, and displayed the reading into the LCD. So this is the whole section of the speed sensing unit, and as we go on decreasing the speed, the speed is going to be reduced. At 0 level. Similarly, we have the another section, that is the humidity sensor section. We can connect the output of the humidity section directly to the voltmeter. So for this, we can connect the output of this humidity sensor simply to the voltmeter section and ground to the ground of the voltmeter section. As we go on increasing the humidity, the reading on this is going to be start increasing in the millivolts. So this is the experiment for the humidity section. This is our smoke sensor section and relay section. Relay section is simply interface when we give the 5 volt power supply to the relay section. the LED start glowing. Basically, relay is used as a switching operation for the higher AC devices. Now, this is our smoke sensor, and we can connect the smoke sensor to this section, positive of the smoke sensor to the 12 volt, ground to ground, and output to the output of the smoke sensor. And now when we produce the smoke to this smoke sensor, these two LEDs will glow and the buzzer starts beeping. We have to common the ground of this smoke sensor, and when the smoke sensor is get activated, the buzzer is start beeping. So this is all about the sensor trainer board with the different sensors.